Okay. So welcome again to everybody who's come. It's good to see you again. I always am happy to see the participants coming in to participate. We started a little bit late today. Hopefully we'll start more punctually on other days. But I do think it's not going to be that long a session today because we're mostly doing some introductions and some brainstorming. We're not really doing an organized mathematical workshop today. So I think we should be finished by 6 o'clock and maybe even a little bit earlier than 6 o'clock. So yes, may only go about 1 hour. So welcome everybody. Reminder, now that I'm recording, can you please type your name into the chat room, and that way we will have a record for everybody's attendance. Um, yes, okay, and so thank you all for coming. Okay, so this is the first workshop of the new term, and already last term we did things a little bit differently than we did in previous terms, and this term things are going to be even more different. I sent out a summary, the syllabus of what we're going to do. Maybe I'll go over that. I'll show the syllabus at some point, but for now, let's just say so. Welcome back. So, if you recall what we did last semester, we studied 4 topics from the high school curriculum. We spent some time on exponentials and logarithms. We spent some time on word problems. We spent some time on geometry with a particular concentration in mensuration. And we spent some time on combinatorics and probability. And when we did the workshops, we didn't run them in exactly the same way as I've been running workshops for the last 4 years, but instead we paid a little bit more attention to the perspective of the teacher in the workshop rather than just the perspective of the learner. We talked about like what things should teachers know, what are particular aspects that you should think about when teaching these things, and what are particular ways to make things more challenging so that a teacher has the appropriate background to teach the subject. So, so the overview of this semester, and I'll show the syllabus after this, is that in this semester we're going to design mini workshops for 3 new topics in mathematics, and there's going to be a vote. We're going to hold the vote today on these topics later on during the session, and the plan is to devote 2 class sessions to a mini workshop on each of the 3 topics. So let me, what did I want to say? And so then, yeah, also for this semester, we're going to devote 3 class sessions to training for coaching students for exams. So for the WAS exam, for the WITS math competition, which we've participated in for the last 4 years. I can certainly obtain copies of old WITS math competitions for practice, but it would be very helpful if someone can help me obtain copies of the old WAS exams. I don't have copies of those, and I don't know how to get them. And I'm wondering if it's possible, maybe some people who are closer with the ministry know some ways of being able to obtain these old copies. And then lastly, at the end of the year, we're going to spend 1 to 2 sessions, at the end of the term discussing, technology for presentations, what's necessary, what might you have, and maybe not everybody will have access to the technology, but I still want to spend some time discussing how to use it, because even if you don't have access now, you may have access later, and these are good programs to know what to do with. So let me actually share the syllabus quickly. So wait, no, not downloads. I need documents. Sorry, and just a reminder in general to please make sure you're muted unless you're asking a question or answering a question. So let me find the syllabus. Okay, so here's the syllabus. I need spring syllabus. Where's my spring syllabus? Spring syllabus. Here we are. Okay, so let me share. Okay, so let's look at this. Okay, so does everybody see the syllabus on the screen? Okay, so this is a mistake over here. That should say spring 2026. I need to remind myself to
Yeah,
fix that.
I'm thinking about it's not Zoom it out as blocks.
Okay, it's too small.
Too small, yeah.
Is that better? That's about as
E,
as much as I can.
okay. Yeah, yeah. Yeah.
Okay. All right, so this is the usual stuff. We don't need to spend much time going over this. The meeting time, based on what people said last semester, I want to just keep the meeting time at the same time as it was last semester. Some people prefer Fridays, but there's also some people who can't make it on Fridays, and they've already planned their schedule around a Thursday class. So, in fairness to those people, I don't want to change the time. So, we're going to keep the time Thursdays at 4:30. Payson, so off with the people who are completing the entire training over the year will receive a certificate. The meeting place is the same. The Zoom room's been the same since the beginning. The password is the same. The YouTube channel is the same. There's nothing different here. All of this is the same from the fall. And then the only thing that's new is this spring semester paragraph over here. So we'll collaboratively construct mini workshops on 2 to 3 topics in the Liberian High School Mathematics curriculum. Additionally, we'll spend some sessions doing practice for various exams, so the WAS exam and the WITS mathematics competition. And lastly, we'll briefly discuss using technology to run remote workshops. And I don't want this to be the main focus of the semester, sorry for the typo there, because not everybody can access this technology. And so I don't want to spend 8 sessions talking about technology, which might only be useful for some people. So I want to spend a little bit of time talking about it at the end because it's important, but I don't want to spend too much time. So we're only going to do it in the last session or the last 2 sessions. Attendance policy is no different from how it's been before. If you miss a session, but you were given data for that session, then you're expected to use that data for the next session, not to get reimbursed again for further data. If you miss lots of sessions, then you can be dropped from receiving data funds. And there is no data available to new participants this semester. So if you are, I mean, I don't think anybody here is a new participant, but if you have a friend who's interested in participating, they are always welcome to join, but they will not be able to receive data funds for the semester. But they are, of course, welcome to join the class if they want to. Okay, Christian, I see you have some objective. I'm really interested, yeah, in only the mathematics section of the WASP. So if you have mathematics section, then I would definitely be happy to see that. That would be helpful for later on in the term. Okay, so we have this schedule of topics, which I sent out a little bit earlier. There isn't very much information here. Today, we're just doing an introduction and an overview, and we're going to vote on the topics today. And at least in topic one, we'll have a small brainstorming session for topic one today. Next week, there's no class. And then we have a pattern with 2 classes devoted to each topic. So topic one is going to be for the next 2 sessions. That's February 5th and 19th. Is the link not working? It seems that check the link. It's not working. Seems like it should be working. Did everybody follow the link that I posted in WhatsApp and it worked fine? Because there's James in the WhatsApp room is saying the link is not working, but I think it should be the correct link. Right? Is the link okay for everyone?
Yeah, that's the same link I used to join. So the one
Okay.
from the WhatsApp group.
Okay. I mean, it should, yeah, should, the link should be fine. Um, let me just respond. Okay, it is working. Okay. Um, you can try replacing the HTTP with lowercase letters if that helps. Yeah, but the link should be fine. Okay. Um, so okay, the room is open. I sent this link. Right. Okay. So we have topic one, topic two, topic three. The reason that's all that it says is because we're going to be voting on those topics today. So I don't yet know what the topics are. And then we have a little break because Passover and I'm away. So we'll have the 3 sessions here on WITS mathematics competition and WASP prep for the students. So these are hopefully before the actual exams, which usually take place in May. So it'll be a good time to focus on this. And then for the last a couple of sessions, we're going to talk about software for mathematics competitions. Okay. So, oh, good. Oh, Christian, you sent me everything. Okay. Thank you very much. I'll have to look at it after the class is over. Okay, so and then we'll have a closing session. So please especially clear your calendars for May 28th. That is going to be the closing session, not only of this semester's workshop, but of the entire program. This is going to complete the 5 years of the program. There will, of course, be an in-person certificate ceremony at some point, which I, again, am not in charge of, and hopefully we can figure out when that will be. But May 28th will be the last virtual Zoom session for the program as we've been running it. Okay, so please try to make sure that you can be there that day. Okay, let me stop the share now. Okay, good. Okay, so that's the general plan of the term. So before we vote on topics, we'll vote maybe in we'll vote in a couple of we'll vote in a few slides. But before, let me switch. Can I do this? Wait, I want to take away the chat and then participants and now chat. Good. Okay. Good. Okay, so before we actually vote on the topics and do some brainstorming, I want to just talk about a few general things. If you're trying to design a workshop on a topic in mathematics, what are some of the things that you need to think about? What are some of the things that I think about when I'm designing, when I'm designing our classes? So, first we have, let me make this bigger just so it's a little bit easier to read. Okay, so first of all, very basic, right? What material should be presented? How much material should be presented? Usually when we're doing a workshop on a topic, we're not covering the entire topic. So even last year, we did a calculus class for all of last year, and I couldn't just teach all of calculus. I had to decide we only have so much time. What is the core material? What is the important material that we need in order to, teach calculus effectively with the limited amount of time that we have? So, especially when we're going to be designing mini workshops that are only going to go for 2 class sessions each, then we're going to need to make serious decisions about how much material should really be included. Because if a topic is something like trigonometry, you can't do all of trigonometry in 3 hours. So we need to talk, what is the most important stuff to do? Okay. It's possible we can have a little bit of flexibility. If one of the workshops needs to go to 3 sessions, that's probably okay. I really don't want to go to more than 3 because then we're going to run out of time. So flexibility to maybe go 3 sessions instead of 2, depending on how timing works, but 3 is the limit. Okay, so another topic, what are the students or the workshop participants most likely to have difficulty with, right? Ultimately, these workshops are for you as teachers. So one thing that's important is, what are your students going to have difficulty with? We should work on those things with some extra effort and try to think of ways to make it easier for students that you may be teaching. And of course, some of these topics, there are teachers who are having some amount of difficulty with them also. So the workshop participants. So what is kind of an appropriate how will we get the most benefit? Which topics in these workshops will give the most benefit? Because participants will really learn something and it will help. So, of course, what is the level of background knowledge of the workshop participants? That can be difficult because sometimes there is a huge variation in how much background knowledge people have. So, it's something one needs to keep in mind, but it's not always possible to aim a workshop at the perfect level of background of everybody. But you need to do what you can to make sure that it's accessible to most people while at the same time being interesting for most people and having people learn something. So fourth point, maybe kind of similar to the first point, what are the most important formulas and ideas, right? These are things that even if you have a limited amount of time, you have to include these things. What is, if there's one thing or 1 or 2 things that you want people to take away from the workshop, what are those things? What is absolute core material that you can't do without? Okay. What kinds of applications, what kinds of applications does this topic have? Right? A lot of times, most people are often, when they're learning math, are going to be motivated by possible applications. So even if you're learning a topic, some topics that can be a little bit harder to come up with good applications that are appropriate for a workshop right away. And for some topics, it's a little bit easier. So, especially when there's a topic that, there are some great applications, then it's usually worth including these in the workshop. And these are applications that might not be in the textbook and might not be things that you had thought to tell your students. But, if you can show an application, often that you can really increase student interest in whatever topic you're working on. Um, so this next one is something that we talked about last term. Is there anything extra a teacher should know to stay a step ahead of the students? So it's one thing to just know all of the material in the syllabus, and it's another thing to know a few things that are maybe not in the standard syllabus and are not being tested on the standard exams, just so that if a student has a question for you, you're more likely to be able to answer it. And also, so if you know these extra things, then the actual material in the syllabus is going to seem easier to you. And when the material seems easier to you, that often makes it easier to teach if you're not, having any confusion about the material that you're teaching. And then the last question is, how can we come up with good questions and examples, right? In these workshops, I'm not just giving you a straight lecture of here's a formula, here's another formula, here's another formula. We're always doing examples. We're always asking questions. I'm usually giving homework questions. And how do you find good questions? And when I say a good question, I don't necessarily mean that the question is so strikingly original or so novel or anything like that. I mean that the question serves its purpose correctly, meaning when you're first seeing a topic, that the question should be a basic question. It's helping you just practice the basic ideas and gain some fluency with whatever the topic is. And then as you become more familiar with the topic, the questions should get a little bit more challenging and they should require you to think more flexibly about your knowledge. You don't want to start right off with a question like that, but you do want to be able to build to a question like that as you spend some more time, doing a workshop on the topic. Okay. So this aspect of coming up with good questions and examples is very important for workshop design. Okay, any questions so far, or comments, or other things that you think should be considered when we plan a workshop? Okay. All right, good. Okay, so let's continue on. Um, okay, so on this last topic, some potential sources for questions. I want to talk. What do I look for? How do I find questions? So, I mean, of course, on any topic, you can just try to make up your own questions, and that's a good exercise, and it definitely helps you understand the topic, not just to make up a question, but to work your question through and decide whether it's a good question, whether it's an appropriate question. So you can do this, but this is somewhat difficult to just sit down. I mean, for some topics, it's easier than others. If you're doing elementary algebra and you want to just make up your own equations, it's not that hard to say, okay, let's try 3x plus 7 equals 16 or something like that. Those questions are not very hard to make up. But when you're going to more difficult topics, it can be taxing to come up with good questions for an individual topic. So it's always a good exercise to do, but it's not the only thing that you can do, right? So some other sources you may want to consult for questions. So first, there are these Art of Problem Solving books, volumes 1 and 2, which I've sent in soft copy many times. And I can always send them again upon request. They have a lot of questions in the back of every chapter. And I will just give a warning for the questions here that some of the questions, especially in volume 2, can be extremely, extremely difficult. So the questions in volume one are usually manageable, although there are definitely some difficult questions in volume one as well. The hardest questions in volume two are very, very hard. They're generally at national and international Olympiad level, and they're challenging even for the top math students in the world. So, especially in volume two, if you look at the questions, a lot of them may not be appropriate. A lot of them you may not be able to do. A lot of them I am not able to do, or at least not without really a long time thinking about them. It's not that every question in volume two is easy for me. Um, but usually these books are good because they mark the hard questions with a little needle icon. So I'll just say here, uh, hard questions. Hard questions are marked with a needle icon. Okay, so the hard questions here are marked with a needle icon. So in volume two, right, you have some very, very hard questions, and not all they're not all appropriate. You may have access to the textbooks from the curriculum document that I sent around. So it seems like the official textbook for the high school curriculum is Mathematics for Senior High School, published by Pearson. So you may have access to that book. The book, of course, will have lots of questions in it, and these are reasonable questions to look at for a topic that's covered in the book. The internet, of course, can be a good source of problems. You can find these using Google or your favorite search engine. So if you're looking for problems on probability or trigonometry or mensuration or bearings, whatever you want, you can just Google bearings problems and you'll find a bunch of links. Some of these links may be good, some of them may be not so good. You're going to have to use your judgment to try to figure out which is which. Another thing that you can look for specifically on the internet is mathematics competitions. So, I mean, in addition to WMC, of course, there's lots of mathematics competitions from all over the world. There's a lot of them in the United States. So you can look for various United States mathematics competitions. One good source of this is AMC competitions. That stands for American Mathematics Council. This is maybe more upper level. There's something called math counts, which is good for maybe lower level, more like middle school level, sixth grade, seventh grade, eighth grade. And then you can just Google for this. Now there's so many more math competitions than there were when I was a kid that there's lots of resources for this. And so this can be a good way of searching for problems, for good examples. And so I give you the caveat that, of course, just because you find a list of questions somewhere doesn't mean that all of them are good questions to use for a workshop, right? You want to think, oh, I guess I lost a word here, ideas. So you want to think, which questions have the appropriate difficulty level, which questions are in good sequence with each other, and which questions are best at elucidating the key ideas. So you might Google and you find something for Khan Academy and it says, 6 trigonometry problems, but that doesn't mean that that list of 6 problems is going to be correct for the workshop. There might only be one problem that's usable. Certainly in the Art of Problem Solving books, not every question is appropriate for every workshop. So you have a source of a lot of problems, but you're going to want to think about what is, kind of the right thing to use. Okay, so these are all potential sources for questions in for various workshops that we may design. Okay, and you may have your own sources. Oh, and I forgot to say also your fellow teachers. You may know other teachers that have a good list of problems, and hopefully they're willing to share it with you. I've definitely seen some participants in the group post all sorts of, usually in the upper level, but post, solutions to 100 calculus problems, so some people that may have large lists of problems that they've solved in a notebook somewhere, and those can also be good sources of problems for running a workshop. Okay, so I missed that because the font is small. So your fellow teachers. Okay, good. Okay, so moving on, I want to talk a little bit about virtual workshops versus in-person workshops, right? So this workshop is virtual, right? And what we can really do right now, if we want to design and actually carry out the workshops, is we have to design virtual workshops. Now, of course, this requires some level of technology, usually to have an effective virtual workshop. I mean, you can do it by just scrolling slides, but for mathematics, just kind of scrolling slides without writing anything often makes it hard for the audience to understand. Okay. So again, please remember to keep your microphone muted unless you're asking a question or answering a question. Okay, so what do I use when I'm doing this? I have to have a tablet, a stylus, a camera, a microphone, right? I mean, of course, you need a camera and a microphone. Your phone has that, but a tablet and a stylus are not always as easy to come by. And so, unfortunately, probably to have a very effective virtual workshop, it often requires having something like this. There are a lot of software programs I use. These programs are all free, but they require a little bit of training to use them. So the slides that I make, I have actually not in this today's lecture is not a good example because I didn't really include any math in the slides, but the program that I usually use to make my slides is called Beamer. It's a very good program for integrating math equations and tables and things like that into slides. And Beamer is based on is based on a typesetting program called LaTeX, which is really a wonderful thing to learn if you can learn it. LaTeX, uses slides that make math formulas, and then once I have my slides in a PDF document, I use a program called GoodNotes which allows you to display a PDF document of slides and allows you to write on them and allows me to do all of the stuff I do with changing the color and erasing things. And of course, it has much more detailed and elaborate functionality than what I actually use. But so it's a good program to fool around with, and all of these programs are free. I want to say one more thing about LaTeX. So LaTeX, or it's really pronounced LaTeX. You pronounce the X like a K. Um, it's a very useful program for general math typesetting. So it's been around for about maybe 40 years, 35, 40 years at this point. And if you learn to use it, if you have access to a laptop, it's probably not a very easy thing to use on your phone. But if you have access to a laptop and you learn to use it, which takes a little bit of time, but is worth it, it really prints beautiful mathematics. And if you look at any modern math textbook or paper or anything like that, these are all typeset using LaTeX. It's a great way for writing any kinds of equations that you might need. And I would say it's also widely used in physics, computer science, economics, and probably also, I mean, I can't speak to the chemistry community or various parts of like electric engineering and things like that, but there are a lot of people who use LaTeX. So this is certainly how I write all of my mathematics now. And unfortunately, it does take a little bit of work to learn, but I would say the one thing that I forgot to write down is there's something called Overleaf, which is the best introduction to this. Okay, so if you download a program called Overleaf, it has a tutorial that will walk you through LaTeX and let you learn how to do some basic things there. So, if you learn to use LaTeX, you're never going to go back to trying to type mathematics in Microsoft Word or something like that again. So there are other options. Of course, there's something called Microsoft's equation editor. And of course, you can do handwriting on slides or on a board with a camera. You don't need to have any typeset mathematics, but this LaTeX is a very nice thing to learn. And I'll show at the classes at the end of the term, I'll give a little LaTeX demonstration. I'll show you how it works. Basically, it's kind of like HTML. If you're doing a website, you write in some source code and it compiles and gives you a PDF document with the math that you're writing in it. Okay. So all of these are possible useful tools for a virtual workshop. And I'll say, and if you happen to have access to the required technology and you would like to give a guest workshop for this group during one of the sessions, please let me know on WhatsApp. And I'll say I can help you design slides, but the group can also help you design slides. We can help you build your workshop. And if you want to be the lecturer during one of these sessions and you have reliable enough internet connection and camera so that people will be able to learn from it, then that's definitely something that would work well. So if you have any interest in that, please let me know on WhatsApp, and we'll try to figure out what's the best way to schedule you in. Okay, any questions about virtual stuff and technology that I mentioned? Okay, good. All right, no questions. Okay, so in-person workshops, of course, we're not doing in-person workshops, but you at some point may want to design an in-person workshop, right? For teachers local to where you are, right? So for an in-person workshop, I mean, all of these things, you can still have slides. You can still, write on a tablet if you want to, or you can write on the chalkboard or whatever. But for an in-person workshop, you have a little bit more flexibility um, for what to do. And the one thing that's a little bit easier to do with an in-person workshop than with a virtual workshop is to try to design a hands-on activity that's going to elucidate a mathematical idea. Pulling this off virtually, especially when you have unreliable network connections, is probably pretty hard to do. So I don't think we're going to be trying to do any synchronous hands-on activities. I think it's going to just degenerate into chaos and it's not going to work so well. But if you're doing an in-person workshop, this is something that is maybe a little bit more viable. And so depending on the topic, when we go through our topics, we can discuss ideas for what might make a good in-person hands-on activity, and we can try to plan the activity even if it is too difficult to actually conduct this activity as a group. It's an activity that you could try doing in your own school or with your own students, something like that. Right. So, I mean, just some basic examples. So, there's a classic exercise in trigonometry where you measure the height of a tree or of a building using a protractor. Not something that we can do using in a virtual meeting, but it's something that I've done in Liberia before when I've gone to organize in-person workshops. So, before this program, I came 3 times and did some in-person workshops. Probability is a great topic for in-person workshops, and it lends itself to hands-on activities using dice or cards or coins. And if you don't have access to dice or cards or coins, you can simulate all of these things by just writing things on pieces of paper. So these are just 2 basic ideas, but when we go ahead and pick our topics, I think trying to brainstorm what would make a good in-person activity for a topic like this is something that we could also spend some time doing as a group in case at some point you might want to run an in-person workshop on the topic. So let me also just say, what are good attributes of an in-person activity? Right. So, I mean, one is does not use much equipment. I don't think we want to design an in-person activity that's reliant on having tons and tons of equipment. So it does not use much equipment. You have to think about how much time it's going to take. Takes the right amount of time. And 3 is, and this one's a little tricky one, it actually helps people understand. Right? Not every possible in-person activity is actually that helpful for understanding the topic, for understanding how it works. So a good activity will actually help and won't just confuse people. Sometimes if it's something with a complicated setup and the connection to the mathematics topic you're trying to work on is not so clear, then doing a hands-on in-person activity possibly is not that helpful. So if you're designing an activity, you want to know, like, is this helpful? And I won't write this down, but I'll mention one more time, right, that, these hands-on activities are not things that you need to think of yourself from scratch. You can search the internet and there are ideas for hands-on activities illustrating, conic sections or illustrating trigonometry or illustrating whatever topic it is that you want to do. So you can search the internet for these things, and there is, there are ideas that you can get, and you might decide, well, this idea is a good idea, this idea is not so good, this is appropriate, this is not appropriate, but it's good to sometimes, maybe this idea can be modified, but it's good to to see what's out there rather than having to just sit down and try to brainstorm everything yourself. Okay, so as part of our workshop organization, we can try to think about what might be a good hands-on activity to do for various topics. Okay. All right, so let's move to the voting now. So we have certain topics that have been proposed for the semester. So I didn't include every topic here. I think some of them end up being kind of not so appropriate for the 2 to 3 week mini workshop that that I envision us running. But these are most of the suggestions that people suggested. So these are the possible topics we're going to vote on. So we have symmetries and transformations, linear programming, which I think is not actually part of the high school curriculum. I don't remember seeing it in there, but it's an extremely important topic, and it's not one that we've ever talked about, and it's very applicable. So I want to include it in the list for that. It's really a good thing to know. So symmetries and transformations, linear programming, differentiation and integration, bearings. People always are confused about bearings. Logical reasoning and formal logic, relations and functions, sequences and series, circle theorems. There was a proposal arithmetic, which I'm replacing with numbers and numeration. That's kind of what the comparable topic is called in the curriculum, and I want to stick to the curriculum if I can. Statistics, of course, this is a huge topic, so we'd have to think, what parts of statistics would we actually try to use? Statistics, by the way, is great for hands-on activities, trying to run experiments and do various tests to see how things work. And then advanced algebra, which again, I don't know exactly what advanced algebra means, but I imagine this means high degree polynomial equations and algebra involving logarithms and trigonometry, things like this. Okay. So I'm going to ask you now. So I'm going to be doing a Zoom poll. So this is the first time I've ever done a Zoom poll. So hopefully this works. So I'm going to launch this poll. So I launched this poll. Now, do you see the poll come up on your screen now or not? So if I launch this poll,
it just came on my side, disappeared.
Oh, so it just came and disappeared. Okay, let me try to do this. So I want to see, yeah, so at most 3 choices. Okay, hold on. Let me end the poll for now, and let me try this again. Hold on.
It was good for my side. It was better for my side.
Okay, I'm gonna relaunch it.
Yeah, relaunch it. I already responded to that.
Okay, so so these are all of the topics that I mentioned here, and you can click on the check boxes, and I want you to vote for at most 3 choices. So you can vote for your top 3 topics that you'd like to do. Okay, good. I see some people have already voted, so that means it seems to be working. Okay, so maybe we'll take until 5:30 to complete your vote. So spend 4 minutes. You can think about what topics you want, and at 5:30 we'll end the poll.
So in case I want to let all of the topics.
Yeah. Yeah, Jasper?
In case I want to select all of the topics.
This is almost all of the topics that I was given in WhatsApp that people sent to me. And there's a couple that I'm not listing here because I don't think they're going to work as well for a workshop. So these are all the topics that people gave to me. Okay, if you're done with your 3 choices, that's great. Just wait a few minutes.
To choose at least 3.
No, at most 3. Choose only at most 3. Yeah.
Okay. I have done mine.
Okay, great. Okay, I'll be back in 1 minute. Take one more minute to think about things. I'll be right back. Okay, I see 12 people have voted so far. We have about 20. Oh, I can't number them. Sorry, I can't number them, but all you have to do is check the boxes. It came in a flash. Okay, so some people are seeing the voting screen and not some people are not seeing the voting screen. So let me know uh, who here has been unable to vote. If so, you can. Okay, you're not seeing. Okay, so I don't know why it's not there. Maybe you weren't in the room when it launched. So if you can send me your preferences message. Hold on. Yeah. Okay, so if you've been unable to vote, at most three options, yes. At most three options, yes. So vote for only three. So you can send me your preferences by Zoom message, but please only send me the preference, only send them to me if you were not able to vote in the poll. I don't want to count double votes. Okay, so you can send me your top three. If the poll is not showing up for you, you can send me the top three. Yeah. Okay, so I'm still waiting for so it looks like 13 out of 20 have sent in their votes. So maybe I'll wait 2 more minutes for you to either respond to the poll, or if for whatever reason, if it appeared and disappeared and you're unable to vote, then you can just type the top three that you want, and you can send them to me and I'll count that for the votes. Mm-hmm. Okay, we'll do 1 more minute and then I'm going to close the poll. Okay, so last chance to vote, 1 more minute. The poll should show up on your screen. If the poll doesn't show up on your screen, then you can just then you if the poll shows up on your screen, you can click at most three choices and click vote. Otherwise, if you're not able to vote on your screen, then send me your choices. You can send it in a message to me. Send me up to three choices from the list. Okay. Okay, so I think we will close the votes now. Last chance. Okay. Statistics, relation to function. Okay, last chance to get your votes in. Okay, linear programming. Okay. Okay, so I'm going to end the poll now. Okay, so here's the results of the poll, and now there's extra votes over here. So what it seems like the top three choices are differentiation and integration, circle theorems, and then I think logical reasoning is the next one. So yeah, logical because it has the 6 votes, but it also had an extra vote over here. So I think so I'm gonna stop sharing here, but it seems like the top three choices, I'll write this down. So top three choices are one, differentiation and integration, two, logical reasoning and formal logic, and three, um, circle theorems. Okay, so these are going to be the topics we're going to do. So wait, no, I don't want to message. Sorry. Admit. So something going on here. Let me close this. Okay. So so these are going to be the topics we're going to do. And I think actually first I would like to start with logic as topic one. So I think in terms of the amount of time we'll want on this, the circle theorems will probably be a shorter workshop. Differentiation and integration, of course, is a massive, massive, massive topic. So if we're going to think about doing a 2 session workshop on that, the question is, are we going to do it about, you know, um, what differentiation integration mean, how to do basic tricks, how to do basic problems. So there's a lot of choices to be made with differentiation integration. Circle theorems, there's probably fewer choices. There's a few main theorems that we might want to do. And then logical reasoning and formal logic are they're okay. Good. No, I see. Yeah. So I think this is I think that it doesn't change the final results. So you got integration as one of yours. Okay. So okay. So I think we'll start actually with logical reasoning. We'll probably start with logical reasoning, then do circle theorems, and then do differentiation integration. So by order, I'll just write this. Uh, Topic one is logical reasoning. Not tops. Wait, no parts. No, no, I don't want that. Sorry. Um, Topic one is logical reasoning. Topic two is circle theorems. And topic three is diff and int as differentiation and integration. Okay. And this, of course, is a topic that we covered in a lot of depth last year. So the question would be if you needed to just do a small amount of it, and maybe the idea is that this is in the high school curriculum and it's probably not given a lot of time in the high school curriculum, although you can correct me if I'm wrong, maybe we want to focus on those aspects of it that are important for the high school curriculum. Okay, so we'll think about that. But yeah, I want to give for differentiation integration, I want to give some extra time to think about that. Okay, great. So thank you for voting and thank you for participating. So these are going to be the topics. And so maybe what I want to do for the next probably just about 15 or 20 minutes, and we'll finish at 6 o'clock, is to do a little bit of brainstorming for logical reasoning. Okay, because this is the topic that we're going to start with. So topic one, you can write, is going to be logical reasoning and formal logic. Okay, so maybe the first thing to do is we should look. This is definitely a topic on the curriculum. So maybe let me actually bring up the curriculum and we can all look at what it says about logical reasoning and formal logic. So let me find logic. It's definitely there. Here we are. Topic one, logical reasoning. What? Sets and logic. Okay. So, okay, let me share my screen for this. Okay. Okay. So it looks like this is this curriculum document that I sent. It has, 69 pages and it has all of the topics that are in the math curriculum for grades 10 through 12 mathematics. Sorry if it's a little small. So this is what we have. And then so the pages that logic is on is I think page 42. So let's see what the curriculum says about logic. Okay, so logic reasoning, so a grade 12 topic. So learners are able to apply concepts to identify a true or a false statement, form negation of simple statements, draw conclusion using implication, deduce equivalent implications from a given implication, and use a Venn diagram to determine the validity or otherwise of implications or conclusions. Okay, so this column is kind of the same as this column. Contents, yeah, usually I find with this curriculum that it's really the first column and or really the second column and the third column that are the most useful to look at. So the contents are statements, implication, converse, equivalence, and negation, and what a valid argument is. I find in these this activities and materials resources are just the same for every topic, so it's not so useful to look at for the individual topic. So these okay, so this is talking about implications or conclusions, kind of I would call this maybe kind of informal logic, and then you also have formal logic. So there's another page, where is it? Page 50, I think, that also had something involving logic. Yes, so this is sets and logic. So this is the other place that logic shows up in the curriculum. So also a grade 12 thing. So let's look mostly at the objectives and the contents. So define sets and use set notation, define and apply subsets, discuss universal set, equal sets, equivalent sets, and listing the elements of a set, discuss event. So that's maybe just straight up set theory. In a mini workshop, we probably wouldn't cover that. We'll just assume that people know it. And then over here, we have, okay, discuss Venn diagrams and use it to illustrate the following operations on sets: intersection, disjoint sets, union, and complement. This seems to be a little bit more related to what we're talking about with logic. Discuss properties of set operations, solve two sets and three sets using Venn diagrams. This is maybe more specific set theory stuff. And then it says review open statements and implication and apply them using sets. This is really where set theory interacts with logic over here. So this reviewing open statements, this is maybe something we would want to do. And then, okay, and the contents over here is basically kind of the same stuff. All right, so it seems like there's maybe a little bit to do with formal logic and set theory, but probably we want to focus for a mini workshop that's going to be 2 classes long. We'd want to focus on formal logic as of itself. So I'm going to write this down as a note. So okay, so this is the logical reasoning. So I'm going to say focus. Okay, let me end my share here. So we want to focus on logical reasoning, which is pages 43 and 44 of the curriculum document. Okay. So, I mean, just with a show of hands, I just want to know is everybody familiar with the basics of formal logic? Has everybody studied this? I want to, know what the background is for everybody. Is this a common topic that everybody has basically studied at some point? even if you're not, fully, confident with everything. Um, but has everybody at least seen this, or for some people is logical reasoning and formal logic something that you've never seen before? Okay. So if you're shy about telling me, that's fine. You can tell me privately in WhatsApp, or you can tell me privately through a message sent to me later on if you want to. But I mean, for what we know about formal logic, let's go back to looking, what's important for designing a workshop on a math topic, right? So I would say for a topic like formal logic, which is not emphasized that much, I would say for designing a workshop on it, you don't want to assume that the audience knows very much, right? So I would say, what is the level of background knowledge of workshop participants? I would say for logical reasoning, maybe not that much. You can correct me if I'm wrong. Okay. So yeah. So what material should be covered? What are the most important formulas and ideas? And my guess is, what are the students and workshop participants most likely to have difficulty with? I think I know the answer to this. And the answer to this is the same as the answer for any other mathematics topic. And the answer to this, I believe, is word problems. Right? I mean, in algebra, certainly what students have the most trouble with is word problems. And in logic, you have word problems also. And if Paul does this, then Jason does that, and all of these, these kind of like essay word problems together that you have to figure out, what some implication means once you write it in terms of language and a paragraph. This is often, something that students are going to have a lot of trouble with. Okay, so what are they most likely to have difficulty with? Probably word problems. What are some of the most basic important formulas and ideas? Well, the good thing about logic is that there aren't that many formulas and there aren't that many ideas. Okay? I mean, somehow the curricular document already tells us this. So curriculum document, let me just blow this up a little. Curriculum doc already tells us this. The curriculum document already tells us what the most important ideas are, at least for the curriculum. So a lot about implication and negation and things like that. Um, what kinds of applications does this topic have? So this is something that maybe not everybody knows, but logic, of course, is the foundation of computer science. So this has lots of applications. So by the topic here, I'm just going to say for this page is logical reasoning and formal logic. And I will say that logic has lots of applications to computer science. Okay, in particular, the basic operations of logic, or and if then, can all be simulated with electrical circuits. And this is what actually tells various lights in a computer, various switches on a computer to go from 0 to 1 and to go from 1 to 0. It's all done in terms of this logic. So logic is extremely related to computer science and how computers work. And of course, in a two-session workshop, we're not going to be able to get very deep into that, but I think that's something that's worth talking about at least a little bit, right? Because people are interested in computers and understanding, when you're learning logic, that it seems like this very abstract philosophical thing. It goes back, people were doing logic 2,000 years ago, but the idea that it's actually applicable to modern technology and especially computers is, I think, something that people will find very interesting. So it's definitely got lots of applications to computer science. Maybe I won't talk about these two questions yet, not today. Maybe we'll talk about them a little bit more next time. But maybe for the rest of today, like, so, okay, what are the most important formulas and ideas? So probably what we're going to want to teach is some sort of logical laws. Logic. Sorry, question? Amaska? Nope. Okay. All right. So let's just go back to our brainstorming page. So going back to our brainstorming page, we have a focus on logical reasoning. Let me just copy what the document says. So I'll say the document focuses on statements, implication, converse, equivalence, um, say negation, and maybe 6 is valid argument. Okay, so right. So we want to understand, which statements are true. How do we get an implication from one implication? Uh, how do we get these other things? So, okay, so this is what the document focuses on. And so if you're going to do a workshop on this, I'm kind of just like going through my thought process on this because, we just decided on this topic. Next week, we'll try to make things a little bit more interactive, just because you'll have had a week to think about this. Okay, yeah, grade 12, third period lesson, logical reasoning. Exactly. So this is on pages 43 and 44 of the curriculum, right? So probably what are some things that we would need to go over to do a workshop on logic? So we have, statement, what are some basic building blocks? So some basic building blocks would be things like, what is a statement? What is a statement? Another building block would be how can statements be logically connected? So this is, standard operations in logic like and, or, if then, etc. They're sometimes called logical connectives. How can statements be logically connected? So what are these logical operators and what do they mean? A third thing is what are laws giving valid implications, right? So some laws giving valid implications, you may have heard these names. There's something called disjunctive inference. There's something called modus ponens and modus tollens. If you don't know what these things are, don't worry. I'm just trying to write out some laws. There's something called contrapositive. There's essentially this is all that you need, but there's various other laws. So let's just say that there are certain ways of making a valid logical implication. Let me see, what do we have over here? Yeah, so how do we find converse and negation? So how can statements be logically connected? What is the process? What is the process and the meaning of negating a statement? What are the process and the meaning of negating a statement? And then maybe I'll just go to the next page. I'll say, what are the formal tools that can help us with this? So formal tools will be things like truth tables, maybe truth tables, statement reason proofs. Etc. It's okay, Marcus. We're going to be finished in 5 minutes anyway. We're almost finished. We're going to finish by 6 o'clock. So what are the formal tools that can help us with this? And I think that's good. These are good so these are maybe building blocks, talking about statements and logical laws and logical connectives and how do we do things like negate a statement and what are certain formal tools that can let us do that? And then maybe not in a building block, but what are some goals for a workshop? Goals. So maybe it's good to set one goal, right? So and here's one goal so I could set one big goal, maybe an overarching goal that encompasses a lot of these things would be participants are able to solve word problems, puzzles based on logical laws. Okay? If you can do that, then you can do everything, right? That's maybe the overarching goal. And then maybe you have some more modest goals if people are seeing this for the first time. So a more modest goal would be that somebody learns what a truth table is, or learns what all of the logical connectives are, something like that. I would just say for a longer workshop, this is not something that we're going to really be able to do, but for a longer workshop, I would say that one should also discuss quantifiers. So things like for all and there exists. So for quantifiers for all there exists. If we had a longer workshop, that would be an interesting thing to do. Maybe another thing to do would be go deeper into links with computer science. Okay, we're probably not going to have time to go very deep into that, but that would be something that would be good to do in a longer workshop. Okay, so these 3 pages here, this is just what comes to me off the top of my head when I'm thinking about trying to organize a workshop on logical reasoning. Of course, I haven't thought about this before because this was just a topic that was voted on. I didn't know that we were going to be doing this. So these are some things that come to me off the top of my head. So what I want to do over the next week is I will send out, first of all, I'm going to find some sources on logic. I already have one book in mind that I think has a very good chapter on logic that I'll send to everybody on the WhatsApp. So I'll send you a PDF of that book. There may be a section in the Art of Problem Solving also. So I'll send some resources for logic. And then what I want you to think about over the course of the week, there's not homework problems or anything. I can just eliminate this page. Hold on. Eliminate this page. No, 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 no. What did I want to do? This page. No, not that page. This page. Okay, so I'm going to send some resources, and then over the week, I want you to think about anything that if you were organizing a workshop on logic, Or if you are participating in a workshop on logic, what's maybe something that you would like to know, something you would like to do, or something that you think should certainly be included? So let me just say, what did I do? Sorry, I will send resources for logic. Okay. And for you, if you can, think about what you would want to be included in a logic workshop slash maybe what you think the needs of most teachers or students would be. Okay. So you have a lot of time to think about this. We have 2 weeks until the next class. So think, because I don't know, I haven't been in Liberian schools teaching this topic, teaching logic. So you maybe have some more experience with this and can say, what is it that people have trouble with? What would need to be covered in a workshop? What do the teachers need to know? What do the students need to know? So hopefully you can think about this a little bit over the next couple of weeks. And in the next class session, we can talk about it, have a little bit more of a brainstorming session. Okay, so again, yeah, there's no class next week. So we're going to start again in 2 weeks on February 5th. Okay, so thank you as always for your attention. Last chance to type your name into the chat so that I have a record for your attendance if you haven't done it yet. And then in 1 minute, I'll stop the recording and that will be the end of class. So thank you again for showing up, and I'm looking forward to a good semester.
Thank you, Dr. Obos.
All right, you're welcome.
All right.
Okay. Thanks. All right, so have a good weekend, everybody. I'll speak to you soon.